Hi, I'm Stephen Harper from InfinityWorks, and today I'm going to be talking about self-hosted action runners on EC2. So first of all, we'll talk about what are GitHub Actions. Then we're going to look at why we should consider using self-hosted actions. Then we're going to look at how we're going to do it. There'll be a demo and then a wrap-up. So first of all, what are GitHub Actions? Well, they're a workflow automation CI/CD tool. GitHub already has a great ecosystem for basically merging pull requests, branching, comments, sharing and collaboration. They've added to that recently a automation tool that allows us to run CI/CD pipelines that are triggered by any event inside GitHub. There's a rich ecosystem of actions which are built by the community, from running Cypress tests to running code coverage to anything you can think of for doing parts of CI/CD pipelines. There's a secret manager that's very good, built into GitHub, that is also integrated into the GitHub Actions. And finally, you pay per minute for this product, and it runs on the GitHub compute and network. So why would we consider self-hosting our actions? First of all, we'd want to consider how we can improve the security of our software development lifecycle. This means that we can choose where we run the build and what operating level security and network security is actually installed in where the builds are running. This removes as well, running it locally, the need for long-lived credentials. Because it runs in Amazon, we can use role-based access to make infrastructure changes to access resources inside Amazon, rather than using credentials that have been stored inside GitHub. Even though it is in their secret manager vault, it's much better if it's done by role-based access. Next, we can consider how we can lower the cost per minute at scale. So if you have a team or a large team or multiple teams using actions, moving them to self-hosted may actually reduce a lot of the operational costs. And then finally, we can look at getting the right size of compute for these actions. Long-running tasks can be much speeded up by choosing and selecting bigger instances that are more suitable for the tasks in AWS. So looking at host actions, the costs. So here we compare 20,000 minutes of AWS build time to 20,000 minutes of GitHub time. Now, looking at this, 20,000 minutes sounds like a lot, but actually per month that's quite low. Some of our clients we can see 10, 20 to 100 times more minutes used a month. And as you can see, the compute and storage times, costs are much less on AWS. And overall, even at 20,000 minutes usage, it seems a pretty safe bet that you're going to save some money running them in AWS. So how are we going to do this? Well, GitHub provide an agent that you can install that picks up jobs from your GitHub projects. The project, which is going to be running as an action, has a GitHub workflow file, and you see this YAML file on the example here, that configures the actions. So if you can see on line 9, it defines that this runs on a self-hosted runner, and it will be running with a Docker image that's from an ECR repository if you look on line 11. So how are we going to do it? Well, first of all, we're going to build a AWS EC2 builder using CDK. This stack will be responsible for building the AMI. The AMI is made of a set of components that are called a recipe, and they choose the order of the components and the installs. And then this recipe runs inside some infrastructure that basically runs in the systems manager automation job. At the end, we get a generated AMI that we can use. The next stack is an example of for development teams to be able to produce their own Docker image that will actually execute the build. It's expected that each team will want to generate their own Docker to do the software generation and any prerequisites that are needed to build their software. This gets published into Amazon ECI. Finally, we then stand up an EC2 stack based on the AMI that we built, and it will be expected to pull the Dockers at runtime from the ECI and run the actions as they get triggered from GitHub. So let's get into a live demo. This is a TypeScript project that is also CDK. It's designed to stand up the stacks that we saw in the diagram previously. So if you look at the package.json, there is an entry point for the CDK at bin github-actionrunner.js. This is responsible for standing up all 4 stacks that are needed for the solution. Here they are included from the CDK folder. Each stack has a number of AWS resources, and some stacks pass the resources between each other. For instance, the base stack is responsible for creating a VPC and a role. These are passed on to the EC2 stack. Let's start standing this stack up. So I'm passing the team name team1 and the name org-builder1 to a deploy command against all these stacks. So this is CDK now, just asking me if I want to have these IAM policies created. I'm going to say yes. And what will happen now is it will start creating some cloud formation from CDK synthesize and send this up to Amazon. So if we have a look now, there's the main base stack in progress. We can see that there's an event stream of things that are happening, and we can see the resources that are being created. This create may take a few minutes because it's going to generate a VPC, it's going to create some NATs, it's going to assign them elastic IP addresses, so I may pause the video and come back once this stack is fully created. So the base stack has now been created and the Docker image builder stack is now going in. This will run the Docker file and generate an ECR image and push it into Docker image and push it into ECR. Let's have a look at that stack while it's building. So this is quite a high level construct. We simply have to provide a link to the Docker file and the name that we want to push it in. It's finished that now, and now it's putting together the AMI builder stack. However, if we go back, we can look at the output from the Docker, and we'll need this Docker image to reference as being the Docker that's going to be our build agent. So if we go into our action here, we'll replace this image with the image we want to build our software. Meanwhile, the AMI builder is being created. So let's see what that looks like inside Amazon. So here we can see a third stack. This has its own event stream. What's happening here is that a EC2 image pipeline is being created. Now this has a lot of components. As you can see, they're all being created now. These are defined in YAML files inside here. So the commands needed to install each component are in here. And the image builder defines them all and gives them a version. These are then layered together as a recipe, and here I've given it a version as well. This recipe has some information about the infrastructure and the roles it will need, a security group, a bucket to write logs to, and then the actual infrastructure config and the pipeline. Once this is complete, we will need to run the EC2 image builder pipeline to generate an AMI. Right, all the stacks are now fully stood up, and we can see we've got an instance ID, but this is an instance from an AMI I built previously, and for this demo we're going to build the whole thing from scratch. As you can see, we've been given a new log bucket as well, where logs during the build will happen and will get put. So let's go and have a look at the EC2 builder and actually set that off now. So here we are looking at EC2 image builder, and here is the new image pipeline. Let's straight away get that running. So when we run this pipeline, an EC2 image will be stood up, and as you can see, I've run this before. This is the fourth time I've executed it, this version. This EC2 image will run inside the VPC that we defined, and it will install all the software that we've defined and create a new AMI. Now there's very little information inside the EC2 image builder console. However, we look in Systems Manager, there's a full breakdown of what's going on under the automation part. Here we can see all the different pending tasks and whether they're in progress or not and what step they're at. So first of all, it will start an EC2 instance, and it will start installing all the different various parts and components that we mentioned in the recipe. So if we look at the instances, we should see that there is a action runner, again with the AMI that we pre-built, so we're going to replace that with the newly built AMI in a minute, and the build itself that's running here. Now because we're using Session Manager, and we've stood this up with Session Manager, we can actually connect to the build instance and actually see what it's doing. However, I'm not going to monitor it like that. I'm going to disconnect from that, and we're going to synchronize the logs down into our Visual Studio here. So if we take the bucket location, and we clear out all the logs here, there's some instructions down here of how to synchronize the S3 bucket. So I'll replace this S3 location with our new bucket, and we'll run an AWS S3 sync. Right now, there's nothing to sync, so the job hasn't fully started yet. However, if we go back into Systems Manager, we should see soon that these jobs start to run. Right now it's in progress, so I'll pause and pick up when it's run a few more tasks. So let's pick up now. Image Builder is well and truly on with building this image. It's got through many of the first set of tasks, and it is through the second set now, a second page. Many of these are sleeping and waiting for various things to happen. So if we go back to the Visual Studio Code now and run a sync, we will actually get a set of log files. These log files contain the application log of the build, which is very verbose, and this will help us debug any problems we've got in building software and installing all the various steps. Again, there's a console log, which is detailed and useful, and errors are quite easy to find in here. So let's go back to the image builder. And we can see here that it's still building. And we can see that instance again is still inside EC2. And we can see it's been doing some things, well, not many things. We can keep synchronizing to pick up more logs, but right now it seems to have stopped. So the image builder is now creating the image. It's stopped the instance and it's creating the AMI. This AMI will take a few minutes to generate. Once it's generated, we will update the CDK and rerun out the stack to switch our EC2 instance over to this newly, freshly built AMI. So the AMI is now available. Let's copy the AMI ID out. Go back and update this inside our CDK JSON file. We'll now redeploy our stack. This will spot that the AMI ID has changed, and it will destroy our current EC2 runner and replace it with the one with the new AMI. We can see this if we go and have a look at the CloudFormation. And there's an update in progress for the action runner. If we look, there'll be a destroy and then a recreation. So we'll create a new one with the same name, but with a different AMI, and it will shut down the other one. So we can see that's happening now. And our new instance is here. Great, that's completed. You can see we have our new instance ID here that's been generated. So what we're going to do now is SSH onto this. Now for our convenience, we've put Session Manager into our SSH config as a proxy command to help us connect to this instance. So we should be able to SSH directly onto this server. However, before we do that, we need to place our public key into the authorized keys. So I'm going to take the instance ID that I've got before and copy it. I'm going to export that into my terminal as the current instance that we're working on. I'm then going to use command line tools to connect. I'm then going to edit the authorized keys, put my public key into this server, disconnect. I should now be able to SSH directly onto this computer without having to use SSM. SSM will be silently used in between me connecting and the connection being created. Great. So the next thing to do, to make our life easier, we're going to be connecting to this using remote SSH. So I'm going to add this new instance. And I'm going to connect to it. This will install a VS Code server and connect me using remote SSH. I can now open the server as if I'm on my own computer. Great, so the last thing to do is to register this as an action runner. If we look at our Github account right now, there are no action runners currently registered for our repo. If I add a runner, I'll be given the manual instructions, but this software has already been installed into our AMI, so all we really need is the unique ID to register it. We simply, for now, copy this temporary token out. So we'll get the command that we need to register this runner. Which is here. So we're going to put our token into this export, and we'll export this temporary token, which will only work for a few minutes, and give it a name. We're then going to cd to the location where the runner is, and we're going to configure and register this action runner. The labels will default to the standard labels that are suggested by action runners. However, we could add more labels if we wanted to target different servers for different labels, but for now I'm going to leave them as standard. What we see now is that in Github we now have an actual registered action runner. However, it's offline. This is because we haven't started it yet. So we're going to install the service so that it starts at boot up, and now we're going to start it. The action runner's workspace is here, and to debug what's going on, it's very simple to drop in and see what's happening and what errors are happening when the builds actually run. But for now, let's just check that it's registered and waiting for work. Great, it is. So let's see this thing in action now. So let's first of all monitor and see what's going on this server. I've gone for a reasonable sized instance. That has 4 cores and 16 gig of RAM. Actually 8 gig of RAM. Great. Let's go back and trigger a build. So as we saw before, the actions that are registered is this push YAML here. So if we go on to our other workspace and we commit a change into this repo, and we'll register the new AMI, this will trigger a build. Now this build would normally be done if we weren't using self-action runners inside GitHub, but actually this triggered build will now run on our action runner. There it is. What we see here is the GitHub Actions has delivered a new payload, which is encrypted. It's arrived, it's been unpacked, and now the action is running. We can see the processing time here, but we can also see all the various build steps occurring here in real time. So what we see now is the container has been initialized, it's been pulled down from the ECR, it's now checked out the code, it's restoring node modules, it's done an npm install, it's synthesizing the stack, and now it's running the full CDK synthesize to check whether the code builds. Next, it will run cowsay, which is a Linux command that we installed as custom software on top of Alpine. That worked, and now it shows out the current role that we're using and then cleans up. It's a simple example, but what you can see is that this action ran on our own self-hosted runner when it was triggered by GitHub events. Now this obviously has a background running cost. Running an EC2 instance 24/7 costs 24 hours a day. We could reduce these costs by using various other tools, and in this example here we have an instance scheduler that is Amazon's product, that is a Lambda, and some other resources including a Dynamo table. Its role is to shut down instances with tags in certain times of the day, and we've used this to stop the fleets of instances so they are mostly running during office hours with just 1 or 2 instances sat around waiting for out of hours actions. Great. So let's go back to the presentation. So what we've seen is a way of standing up action runners inside AWS EC2 to pick up and run tasks with a role that allows them to stand up resources in AWS, improving security, allowing you to choose the resources you want in your build, the network, the software, and completely control the pipeline end to end while still taking advantage of GitHub action runners. VintiWorks has got this made into a solution that we can deploy into any client. We can build a new CI/CD pipeline or migrate into GitHub Actions if that's something that you're looking for. Also, we have a repo that we use internally that may become available soon. Thanks for your time, and thanks for your time today.